we have spent, the last 10 years completely obsessed with computers that can see and computers that can talk.
Mm-hmm.
We've pretty much conquered the digital world.
Mm-hmm.
I mean, you can ask an AI to write a sonnet or, make a picture of a cat in space, and it just does it instantly.
Right.
But the action part, actually moving atoms in the real world, that has been this stubborn final frontier.
It's the difference between a brain in a jar and a body out in the world.
Mm-hmm.
And that is exactly where the big shift is happening right now. We're not talking about chatbots anymore.
No.
The whole industry is moving toward what they call do-bots.
Mm-hmm.
And that's where we get into vision language action models, or VLAs.
From text to torque. That's the phrase that really stuck with me reading through the docs on Figure's Helix architecture.
Yeah.
This is the system running inside their humanoids, and it honestly feels like the first time we're seeing a legit chat GPT for robots. But instead of just spitting out a paragraph, the VLA sees a messy kitchen, hears clean this up, and outputs motor control.
Which is a massive paradigm shift. I mean, think about it. The last wave of AI was all text in, text out.
Right.
Or maybe image in, text out. But a VLA like Helix, it changes the output entirely. It's outputting physical movement. It's deciding, how much current to send to a motor in a whisk joint to rotate it 4 degrees.
And what makes Helix, specifically this new Helix 02, so interesting is that it's not building on the old way of doing things.
No, not at all.
The sources really highlighted how old robotics was so modular. You had these separate blocks of code, one block to see, one to plan, and a totally different one to move.
And that modularity made them incredibly
brittle.
Incredibly brittle, yeah.
Mm-hmm.
In the source material, there's this amazing reference to the old code stacks needing something like 109,000 lines of C++ code.
Just to stand up.
Just to get a robot to stand up and walk without falling over.
Yeah.
That's over 100,000 lines of code just to fight gravity.
It makes me think of those old videos, robots taking 20 minutes to open a door and then a light breeze just knocks them over.
Exactly.
Yeah.
But Helix unifies this. It uses a single neural network. It maps pixels directly to whole body actions. It's replacing all those hard-coded heuristics.
If this then that rules.
Gone. Replaced with learned behaviors. It's the one brain concept. But we do have to be a little careful with that term.
Okay.
Because as we dive into the specs, Helix isn't just one giant, undifferentiated blob of a neural net. It's actually structured. It's a hierarchy that mimics human cognition. The documentation calls it a thinking fast and slow architecture.
I love that reference to Kahneman.
Mm.
So, okay, let's break this down because the layers really explain why this robot doesn't just, freeze up when it sees something new.
Right.
So at the top, you have what they call System 2. This is the big brain.
System 2 is a vision language model, a VLM. It's a massive one, roughly 7 billion parameters. And its main job is semantic reasoning, long horizon planning.
The common sense part.
That's it. It looks at the room, it identifies objects, it understands the context of a command. So if you tell the robot, pick up the desert item, and you've got a cup, an apple, and a toy cactus on the table.
System 2 is the one going, okay, cactus, desert, that's the one.
It creates that high-level plan. But here's the catch. System 2 is slow, in computational terms anyway.
Yay, how slow are we talking?
It runs at about 7 to 9 hertz. So it's updating its understanding of the world maybe 9 times a second.
Which sounds fast to me, but for a robot that's balancing on 2 legs, 9 times a second is an eternity.
Mm-hmm.
If you start to trip, you can't wait a tenth of a second to decide how to catch yourself.
You'll be on the floor.
Yeah, you're on the floor before the next update even comes through.
And that is precisely why you need a faster system underneath it. Which brings us to System 1.
Okay.
This is the visuomotor policy. It's much smaller, a leaner model, about 80 million parameters compared to the 7 billion.
It's fast.
Very fast. It runs at 200 hertz.
200 times a second. So the analogy I kept thinking of was driving a car. System 2 is me, the conscious driver, looking at the GPS and deciding, okay, I need to merge left to get to the grocery store. That's the plan.
And System 1 is?
System 1 is my hands and feet doing the actual work without me thinking about it. Keeping the car centered, pressing the gas just right. I'm not consciously thinking, turn wheel 4 degrees. My brain just does it.
That is a perfect mapping.
Yeah.
System 2 sets the goal, merge left. And System 1 handles the immediate hand-eye coordination to do it. But the Figure team took this even further with Helix 02.
Right.
They realized even 200 hertz wasn't fast enough for the basic physics of just staying upright. So they added another layer. System Zero.
System Zero. Okay, so we're getting into the really subconscious stuff now. This is like the spinal cord of the machine.
That's a great way to put it. It's a learned whole-body controller, and it runs at 1 kilohertz.
1,000 times a second.
1,000 updates per second. It's handling balance, gravity, contact forces, all the low-level stuff.
Yeah. So why do you need that kind of speed? Is that just for show?
No, it's absolutely necessary for what roboticists call loco manipulation.
Which sounds technical.
It just means being able to walk and use your hands at the same time. Think about the physics when you open a heavy door. You don't just stand there and pull with your arm, right?
No, you lean back, you shift your weight, plant your feet.
Exactly. If you just pulled with your arm, the door would pull you over. Old robots couldn't do this because the walking code and the grabbing code didn't talk to each other fast enough. System Zero integrates them. It's like digital muscle memory.
So it can do things like nudge a door with its hip while its hands are full.
Or adjust its stance instantly when it picks up a heavy box.
There was this one moment in the Helix O2 demo that really drove this home for me. The dishwasher nudge. Did you catch that?
Oh, yeah. It was hard to... It was so subtle, but the implications are just huge.
Okay, so for anyone who hasn't seen the video, the robot is loading a dishwasher. It's done. It needs to close the door. But the handle is really low, like near the floor.
Right. And for a humanoid shape, bending all the way down to grab that
Right.
is awkward. It shifts your center of gravity way forward. A traditional robot would have to do a perfect deep squat, or it would just fail.
But Helix O2 didn't squat. It lifted its foot and gave the bottom of the dishwasher door this little upward kick.
Just a nudge.
Yeah, just a nudge. And that popped the door up a few inches, just enough so the handle was an easy reach. Then it grabbed it and closed it.
It was so human. It's exactly what I would do if I was feeling lazy or my hands were wet. But the critical part here is that no engineer wrote a line of code saying, if door handle low, then use foot.
So it wasn't scripted.
Not at all. VLA learned that behavior. It understood the goal, close the door, and it understood its own body and the physics of the room. It figured out that using its foot was a valid, maybe even optimal solution.
That's that creativity or adaptability that separates a doobot from, a factory arm welding the same spot all day. But this brings up a huge problem. How do you train a model to do that? We train ChatGPT on the whole internet, but there's no Wikipedia for robot actions.
That is the data bottleneck. There is no internet-scale library of how much torque to apply to a dishwasher door. So Figure had to basically manufacture their own data. They call it Project Go Big.
Right, I was reading about this. They didn't just have robots flailing around in a lab. They used humans.
They realized the best training data for a humanoid robot is a human. So they collected just massive amounts of egocentric video.
First-person footage.
Exactly, of people doing chores in actual homes.
Yeah.
They partnered with Brookfield to get access to real, messy living spaces.
So the AI watches hours of me folding laundry or walking through a cluttered room. But how does that translate to the robot? I mean, I have legs, it has motors, my vision is biological, it's digital.
This is where zero-shot transfer comes in. Helix watched these videos, and it learned the concepts of navigation and manipulation. It learned how to move through a messy room, not by memorizing the room, but by understanding spatial relationships. It transferred the human behavior to its own control policy without needing a robot to physically practice every single thing first.
But there's a missing link. Watching a video is one thing, but understanding what's happening is another. Who is labeling all this footage? You can't have people sitting there typing, frame 1, hand reaches for cup.
Impossible at scale.
Mm-hmm.
So they automated it. They use a vision language model to watch the raw video and write the instructions. The AI generates the text labels like the human is folding a towel, which then get fed back into the training for the VLA.
It's an auto-labeling loop. The AI is basically writing its own textbook.
Exactly. Which explains how it gets that semantic understanding we talked about earlier.
The desert item example.
Yeah. The system isn't just matching pixels, it's matching concepts. With old robots, you had to be so specific. Go to coordinates XYZ and grasp object ID 44.
And if object 44 moves an inch, the robot just grabs air.
Right. Helix operates on the concept. It knows desert. It associates that with cactus, finds the visual match, and then generates the motor actions to grab it.
Speaking of grabbing,
Yeah.
we have to talk about the hardware. Because you can have the smartest brain in the world, but if your hands are numb, you're going to crush that cactus.
Oh, the hardware-software symbiosis is absolutely vital here. Helix O2 isn't just relying on cameras in its head. It has tactile sensors in its fingertips that are incredibly sensitive.
How sensitive?
The specs say they can register 3 grams of force.
3 grams?
Yeah.
That's what, lighter than a sheet of paper?
Pretty much. It allows for incredible nuance. The VLA adjusts its grip force in real time based on what it feels. It can pick up a paperclip, but it can also handle a crushed plastic bottle without cracking it more. It feels the object.
And they solved the occlusion problem, too. You know, if I'm carrying a big box, I can't see my feet. I can't see where I'm putting it down.
Which is a huge issue for robots with head-mounted cameras. So Figure's solution was to put palm cameras inside the hands. The VLA just seamlessly switches feeds. If the head camera's blocked, the brain just prioritizes the view from the wrist to see the table.
It's literally having eyes in your hands. And that combination, the feel, the cameras, the VLA brain, is what let them claim that 4-minute dishwasher task with 0 human intervention.
0 intervention is the key metric for sure.
But I want to push back on this a little bit. We see 0 intervention in a controlled demo video, which is great, but they also put this thing in a BMW plant. The data says it spent 11 months there, handled 90,000 parts, worked on 30,000 cars. That sounds impressive, but then I saw another stat, 85% success rate on unseen tasks.
That's an important distinction to make.
It is, because if I'm the plant manager at BMW, 85% sounds risky. If a robot drops 15 out of every 100 windshields, I'm firing that robot. So how do we square those numbers?
So the 85% figure refers to the 0-shot performance on novel items, things the robot has never seen before. A random tool, a piece of clothing.
Ah, okay.
In the BMW plant, for the specific task of placing sheet metal, the reliability was way, way higher because it had practiced that.
Okay, that makes a lot more sense. So the sheet metal task was dialed in.
It had to be. It was placing metal within a 5mm tolerance in under 2 seconds. But the VLA advantage there wasn't just accuracy, it was recovery.
Right. The correction and recovery.
Because it's a neural net, if it slipped a little or the metal was bent, it didn't just freeze and throw an error code like a normal robotic arm would.
It micro-adjusted?
It just flowed. It treats the error as another input to correct for, just like a human would if you fumbled your keys. You don't stop and reboot, you just adjust your grip. That resilience is what let it run for 1,250 hours in a real factory.
So the 85% is actually a badge of honor for the unknown stuff. It means you could throw a random teddy bear at it, and 8.5 times out of 10, it catches it without ever having seen a teddy bear before.
Exactly. And that capability, dealing with the unknown, that leads us to maybe the most provocative idea in all the source material, the expansion rule.
This is where things get a little bit sci-fi, but in a very grounded way.
Yeah. The expansion rule basically says we are moving away from programming individual robots and toward collective learning.
Okay, unpack that.
Well, think about how we learn. If you learn a new card trick, I don't know it until you teach me. But with Helix, if one robot in some house in Ohio learns that nudging the dishwasher with its foot is a good strategy.
That data gets captured, labeled, and fed back into the central model.
Which means, in theory, the next software update pushes that physical wisdom out to every other Figure robot on the planet.
So we're not just building machines anymore. We're building a shared, growing brain for physical interaction.
That's the idea.
That is massive. It means the rate of improvement isn't linear. It's exponential. Every mistake one robot makes anywhere prevents every other robot from making that same mistake.
It's the death of the isolated machine. We are moving from robotics to a scalable physical intelligence.
Wow. It's thrilling and honestly a little overwhelming to think about. We've gone from thousands of lines of code just fighting gravity to a shared brain that learns to kick doors closed.
It's the bridge between knowing and doing, and we are just starting to step onto it.
If you haven't seen that dishwasher video, go find it. It's a small nudge for a robot, but it feels like a giant leap for the industry. We'll be tracking how Helix evolves, but for now, thanks for diving deep with us.
Always a pleasure.